Imagine this for a moment. You're floating in space, surrounded by silence so complete it feels unreal. No air, no sound, no sense of up or down. Everything seems calm until it isn't. One small error, one miscalculation, and suddenly your trajectory changes. You're no longer drifting freely through the cosmos. You're falling, not toward a planet, not toward a star, but toward something far more extreme. A black hole. At first, it doesn't look that dangerous. From a distance, a black hole doesn't resemble the swirling monsters we see in movies. It's invisible, hidden against the darkness of space, betrayed only by the glowing disk of superheated matter spinning violently around it. This is the accretion disk, gas, dust, and entire stars being torn apart, heated to millions of degrees, and dragged toward oblivion. And now, you're headed straight for it. As you get closer, strange things begin to happen. The stars behind the black hole start to warp and stretch, forming eerie rings of light around the darkness. Space itself bends like glass under pressure. Time no longer feels stable. Seconds seem longer. Movements feel delayed. You check your instruments, but they offer little comfort. The gravity here is unlike anything humans were ever meant to experience. Then you realize something chilling. There is a boundary around a black hole known as the event horizon. It's the point of no return. Cross it and escape becomes impossible, no matter how fast you travel, no matter what technology you have. Not even light can outrun the gravity beyond that point. And as you fall, that invisible boundary rushes toward you. Here's the terrifying twist. Contrary to what many people believe, you wouldn't necessarily die the instant you cross the event horizon. In fact, depending on the size of the black hole, you might not feel anything at all at first, especially if this is a supermassive black hole, like the ones that sit quietly at the centers of galaxies. From your perspective, the crossing could feel completely normal. No alarms, no sudden explosion. Just a quiet, irreversible step into the unknown. Meanwhile, far away from you, an outside observer would see something very different. To them, you would appear to slow down as you approach the event horizon. Your movements would become more and more delayed, your image stretched and red-shifted, fading into darkness. From their point of view, you never quite cross the boundary. You simply freeze in time, suspended forever at the edge. But for you, time continues to flow. You fall inward, and the universe you knew begins to disappear. Inside the black hole, reality becomes deeply unsettling. Light behaves strangely, bending around you in impossible ways. Directions lose their meaning. The idea of forward or backward no longer makes sense. Space and time swap roles, forcing you toward the center just as inevitably as time forces you toward the future. There is no turning back. Every second carries you deeper. Your body, meanwhile, starts to feel the effects of extreme gravity. A phenomenon known as tidal forces begins to stretch you. The gravity at your feet is stronger than the gravity at your head, pulling you apart inch by inch. Scientists call this spaghettification, a horrifying but accurate description. Your body elongates, stretched thin like spaghetti, as atoms themselves struggle to hold together. And yet, in this thought experiment, you remain conscious. You are aware. You think. You remember who you are and where you came from. Your heartbeat echoes in your ears, the last familiar rhythm in a universe that no longer follows familiar rules. You try to comprehend what you're seeing, but language fails. Human intuition was not designed for places like this. Time becomes your greatest enemy and your strangest ally. Due to extreme time dilation, minutes for you could equal years for the outside universe. Entire civilizations might rise and fall while you experience only hours. The universe beyond the black hole continues without you, aging rapidly as you fall into a place where time loses its meaning altogether. This is not just a journey through space. It's a journey through the limits of physics itself. At the center of the black hole lies the singularity, a point of infinite density where our current understanding of physics completely breaks down. No equations can fully describe it. No experiment can replicate it. It is the ultimate unknown. So what would the next 24 hours really be like? What would you see? What would you feel? Would consciousness survive as reality itself unravels? Over the next part of this journey, we're going to follow those 24 hours step by step, from the moment you cross the event horizon to the deepest regions of a black hole, where time, space, and existence itself are pushed beyond their limits. This is what happens if you fall into a black hole and somehow survive for 24 hours. After crossing the event horizon, the first thing you notice is how normal everything feels. There's no explosion, no sudden darkness swallowing you whole. In fact, if this black hole is supermassive, the gravity at the horizon is spread out enough that your body doesn't feel instantly torn apart. For a brief moment, it almost feels like nothing has changed. You're still thinking, still aware, still falling. But something is very wrong. No matter how hard you try to slow down, turn around, or escape, every possible path forward leads deeper inside. The universe has quietly removed all other options. As the minutes pass, light around you begins to behave in deeply unsettling ways. Photons curve, looping around the black hole before reaching your eyes. You might see multiple distorted images of the same stars warped into glowing rings that wrap around the darkness. Some light you see may even come from behind you, bent forward by gravity. The universe no longer obeys common sense. What you're seeing is space-time itself folding under extreme mass. During the first few hours, time becomes confusing, your internal clock feels normal, but the outside universe is racing ahead. Every second you experience equals many seconds, minutes, or even years outside, depending on the black hole's mass. If someone were watching from far away, they would never see you cross the event horizon at all. To them, you would appear frozen, slowly fading into darkness. But from your perspective, you are moving forward normally, falling deeper into a place where time and space trade roles. Around hour 6, tidal forces start to make themselves known. Gravity is no longer uniform across your body. The pull at your feet is stronger than the pull at your head, stretching you lengthwise. At first, it feels like pressure, a strange heaviness along your spine. But slowly, relentlessly, that pressure increases. This is spaghettification beginning, the stretching of matter caused by extreme gravitational gradients. Your body is no longer a single object falling through space. It is being pulled apart by the geometry of space-time itself. Despite the pain and disorientation, consciousness remains. Thoughts slow, not because your mind is failing, but because reality itself is becoming harder to process. The concept of direction dissolves. Inside the event horizon, all possible futures point toward the singularity. You are not moving toward it in space, you are moving toward it in time. The singularity is not ahead of you. It is your future. As hours pass, external light sources fade. The accretion disk and distant stars are left behind, stretched into thin lines of radiation before disappearing entirely. Darkness surrounds you, but it is not empty. Space here is packed with energy, curved to an extreme degree. Quantum effects begin to dominate. Virtual particles flicker in and out of existence. Even the vacuum is unstable. By hour 12, the black hole's interior becomes a realm where our current laws of physics begin to fail. General relativity predicts your inevitable destruction, but it cannot describe exactly how it happens. Quantum mechanics hints at strange possibilities, information preservation, exotic states of matter, even connections to other regions of space-time. But no theory fully agrees with another. You are now in a place science can describe only with uncertainty. Your body is stretched beyond recognition. Atoms struggle to remain bound. Chemical bonds break. Subatomic particles drift apart. And yet, for this thought experiment, awareness persists just long enough to understand the scale of what is happening. The universe is not hostile here. It is indifferent. You are not being attacked. You are simply experiencing gravity in its purest, most extreme form. As the final hours approach, time itself loses meaning. The closer you get to the singularity, the more extreme the curvature of space-time becomes. Equations predict infinite density, infinite gravity, infinite curvature. These infinities are signals that our understanding has reached its limit. Something else must exist beyond them, a deeper theory we have not yet discovered. In these final moments, all paths converge. The idea of survival no longer applies in a human sense. But the information that makes you your particles, your energy, your imprint on space-time does not simply vanish. According to some theories, it may be encoded on the event horizon itself, preserved in ways we do not yet understand. In others, it may contribute to the black hole's mass, subtly altering its future. After 24 hours, the journey ends not with a dramatic explosion, but with silence. The singularity represents the edge of knowledge, where space, time, and identity dissolve into something fundamentally unknowable. Falling into a black hole is not just a physical experience. It is a confrontation with the limits of reality, a reminder that the universe is far stranger, deeper, and more mysterious than anything we experience on Earth. And perhaps the most unsettling thought of all is this: black holes are not rare. They are everywhere, quiet, patient, waiting at the centers of galaxies. And while we may never fall into one, they continue to shape the universe in ways we are only beginning to understand. Falling into a black hole is not just a thought experiment about survival. It is a journey that forces us to confront the deepest limits of human knowledge. Throughout these 24 hours, we followed a path that no human could realistically endure, yet one that science allows us to imagine. And what we discovered is something both terrifying and humbling. A black hole is not simply a cosmic destroyer. It is a boundary, a place where our understanding of reality begins to fail. What makes this experience so unsettling is not the violence of it, but the silence. There is no dramatic explosion, no sudden end that feels final. Instead, there is a gradual loss of familiar concepts. Time stops behaving like time. Space no longer acts like space. Cause and effect blur together. Inside a black hole, the universe does not feel hostile, it feels indifferent. And that indifference is far more frightening than chaos. Yet, black holes are also reminders of how powerful human curiosity truly is. We have never visited one, we may never send a probe beyond an event horizon, and still, through mathematics, observation, and imagination, we can describe what happens there with incredible precision. Every equation, every simulation, every image we create is a testament to our desire to understand the unknown, even when the unknown resists explanation. Perhaps the most profound realization is that black holes are not anomalies. They are a natural consequence of the universe obeying its own rules. They form from dying stars, shape galaxies, and influence the motion of billions of suns. Our own galaxy is held together by one. These cosmic giants are not rare accidents. They are fundamental features of reality. And then there is the question of information. Does anything truly disappear inside a black hole, or is everything preserved in some form, encoded on the fabric of space-time itself? This question remains one of the greatest mysteries in modern physics. If information survives, then nothing is ever truly lost. Every moment, every particle, every trace of existence leaves a permanent mark on the universe. In that sense, the journey into a black hole becomes strangely poetic. It is not just about destruction, but transformation. Matter becomes energy. Energy becomes curvature. Curvature becomes mystery. And at the center of it all lies a singularity, not just a point in space, but a symbol of how much we still have left to learn. So when you look up at the night sky, remember this: beyond the stars you can see, beyond the galaxies you can imagine, there are places where reality itself bends beyond recognition. Places that challenge our intuition and expand our understanding of what the universe truly is. We may never fall into a black hole, but by asking what would happen if we did, we take one step closer to understanding our place in a universe that is vast, mysterious, and endlessly fascinating. And sometimes, the questions we ask are just as important as the answers we find.